A power management chip smaller than a fingernail sits inside your phone charger. It has no artificial intelligence inside it, no neural network, nothing resembling the silicon powering a data center. It was designed on a manufacturing process older than most generative AI models. Yet in the second quarter of 2026, that unglamorous chip helped a Chinese foundry more than triple its profit. Nobody built it to ride the AI boom. The AI boom found it anyway, and squeezed. Every headline about the AI boom points to the same handful of chips. The accelerators inside NVIDIA and AMD hardware, built on the newest, smallest manufacturing processes TSMC can produce. Those chips get the attention. They are not where the squeeze is worst. Two tiers of semiconductor manufacturing exist side by side. One is the advanced tier, 3 nanometer and 5 nanometer logic, wafer capacity booked years in advance, reserved almost entirely for AI accelerators and the packaging that surrounds them. The other is the mature tier. Chips built on processes from a decade or more ago, unglamorous by comparison, running at 28 nanometers, 40 nanometers, sometimes older. Mature node chips regulate power, convert voltage, manage batteries, and connect sensors. They sit inside smartphones, vehicles, industrial equipment, and the power delivery components that keep AI server racks from overheating or tripping their own circuits. For years, mature node capacity ran with room to spare. Chip makers serving that tier competed on price, and margins stayed thin. Semiconductor Manufacturing International Corporation, better known as SMIC, spent much of the last decade in that thin margin tier, largely locked out of advanced node manufacturing by export controls that block it from the newest lithography tools. SMIC could not build the accelerators. It could build almost everything else. That distinction, once a limitation, has become the whole story. As AI infrastructure spending pulled advanced node capacity toward accelerators and the components that support them, mature node fabrication lines that once sat half-empty started filling. Orders that once might have gone to Taiwan or elsewhere began landing at Chinese foundries instead, not because buyers preferred them, but because capacity elsewhere had nowhere left to give. SMIC's own second quarter filing points to what its executives call the industrial momentum and spillover effects generated by AI, feeding what it describes as broad-based demand for integrated circuit manufacturing across its production lines. What changed was not SMIC's technology. What changed was the shape of global demand crashing into a capacity ceiling nobody built for artificial intelligence in the first place. Why would a foundry that could not compete for AI's most advanced chips end up as one of the AI boom's clearest financial winners? That question sits underneath every mature node order now landing in Shanghai instead of Hsinchu, and it will not stay unanswered for long. Another question follows closely behind it. Once those orders arrive, who eventually absorbs the higher price? SMIC's own second quarter results, published on August 13th, reported revenue of just over $3 billion, $3,056 million, up 36% from $2,209.1 million a year earlier, and up 20% from the first quarter of 2026. That is not a modest recovery. That is a foundry outgrowing the broader chip cycle around it. Net profit told a sharper story. Reuters reported second quarter net profit of $479.2 million, more than tripling year over year and landing nearly double the $253.4 million analysts tracked by LSEG had forecast. What kind of demand model gets a foundry's profit wrong by nearly half? Margin told the same story from a different angle. Gross margin reached 25.3% in the second quarter, up from 20.1% in the first quarter of 2026 and 20.4% a year earlier, according to SMIC's own filing. Rising margin during a demand surge is not an accident. It is pricing power, the clearest sign that a supplier, not its customers, is setting the terms. Capacity utilization backs up the same conclusion. SMIC's full-year 2025 results put capacity utilization at 93.5%, up 8 percentage points from the year before. In a filing the company published in March 2026, a fab running at that rate is not scrambling for orders. It is turning them away or deciding which ones to keep. Reuters reported in March that China's share of global mature node manufacturing capacity stood at 37% in 2026, projected to climb to 42% by 2028 as advanced node lines stay reserved for AI accelerators. Every percentage point in that shift is an order that used to go somewhere else. SMIC has said publicly that it intends to flexibly allocate existing capacity and accelerate the qualification of new production lines to help ease supply constraints across the industry chain. That is a company deciding, in real time, who gets the wafers it has left. The fingernail-sized power chip from the opening image belongs to exactly this category of semiconductor manufacturing: mature, unglamorous, and suddenly indispensable. SMIC's chairman, Liu Xunfeng, credited artificial intelligence, data centers, and autonomous driving with leading what he called a new round of rapid growth for the industry in the company's 2025 annual results. None of those sectors make advanced logic chips at scale in China yet. All of them need mature node chips by the truckload. The squeeze is not confined to logic chips built at mature nodes. IEE Spectrum reported that DRAM prices climbed 80% to 90% in the first quarter of 2026 alone, citing Counterpoint Research, as the same AI infrastructure boom pulled memory production toward high-bandwidth chips for accelerators. Memory, logic, packaging. Different layers of the same supply chain, squeezed by the same appetite. SMIC expects that pressure to continue, guiding third-quarter revenue up another 2% to 4%, and gross margin toward 26% to 28%. Put all of this side by side and a ledger starts to take shape, with a clear winner and no clean resolution for everyone else. SMIC sits on the winning side of it. Global mature node capacity controlled by China stood at 37% in 2026, and forecasts published in March put that share at 42% by 2028. That is not a hypothetical trend line. It is wafers, physically moving from one country's fabs to another's, one order at a time. Profit tells the same story from Wall Street's side of the ledger. Analysts tracked by LSEG expected SMIC to earn $253.4 million in the second quarter. SMIC earned $479.2 million instead, nearly double what Wall Street modeled. A forecasting miss that size in a market this closely watched means the consensus model was built for the old mature node cycle, not the one AI created. If the model was wrong once, what should anyone conclude about the 2028 number? The same mispricing shows up one layer over, in memory. The market for high-bandwidth memory chips used in AI accelerators was worth $35 billion in 2025. Industry projections point to $100 billion by 2028, according to reporting in IEE Spectrum. Different chips, different customers, same underlying force pulling every category of supply toward artificial intelligence and away from everything built before it. Winners in that ledger monetize scarcity. SMIC is one of them, and its rising margin is the proof. Losers absorb the cost of that same scarcity without getting to set a price. Electronics manufacturers that depend on mature node parts for power management, automotive, and industrial equipment sit on that side. When a foundry raises prices while running near full capacity, as SMIC's own margin data shows it is doing, that cost does not evaporate. It moves downstream, through component costs, toward device makers and eventually the buyers of the finished products. That is the second-order consequence nobody priced in. A boom in advanced chips quietly inflating the cost of the ordinary ones. SMIC did not choose this position by building something new. It ended up there because everyone else's capacity filled up first. That is not a controversial claim. It is what a capacity ledger looks like when one side of global demand outgrows the other. None of this is as settled as a ledger implies. SMIC's own language, about spillover effects and broad-based demand, comes from the company describing itself, not from an independent audit of why buyers are choosing it. That distinction matters. A company explaining its own results is not the same as a customer explaining why an order moved. Reuters reporting on analyst estimates confirms the market was surprised. It does not confirm every reason SMIC gives for that surprise. The 42% capacity share figure for 2028 is a forecast, not a recorded outcome. And forecasts about chip capacity have missed before, in both directions. How much of that 42% projection survives an actual slowdown in AI spending? SMIC's 93.5% utilization figure describes all of 2025, not the second quarter of 2026 specifically, and utilization can fall as fast as it rises when demand cools. The claim that higher component costs eventually reach electronics manufacturers and consumers follows standard supply chain logic. No source in this ledger reports a number for it. No source in this reporting states what a mature node price increase adds to the cost of a finished phone, car, or controller. That gap in the record is worth stating plainly, instead of filling it with a number that sounds precise but was never verified. There is also genuine disagreement buried in this story about how long the mature node squeeze lasts. SMIC's own guidance points toward continued tightness into the third quarter of 2026. IE Spectrum, citing Intel's chief executive, reported that broader chip supply relief across the industry is not expected before 2028 at the earliest. Those timelines describe different parts of the same supply chain, and neither has been tested by an actual downturn in AI spending. If that spending slows, mature node orders could just as easily reverse course, and the foundries now benefiting most would feel it first. Nothing in the current dataset rules that out. It only shows what has already happened, measured through the third quarter of 2026 and no further. That limit deserves to stay visible, not smoothed over for the sake of a cleaner story. That fingernail-sized power chip from the opening is still just a power chip. It has not changed. What changed is everything around it. A global map of semiconductor manufacturing capacity, redrawn by demand nobody planned for, with SMIC positioned as one of the clearest financial winners of the shift and everyday electronics makers left to absorb whatever costs come next. No part of that outcome required a breakthrough. It required a shortage, and a foundry patient enough to wait for one. That is not a dramatic ending. It is a supply chain doing exactly what supply chains do under pressure, rewarding whoever still has capacity left to sell. Facts over fear.